Hello, this is Brent Einoff presenting Assignment 3 Part 2. Here we have a ANN with backpropagation implemented in Java. Implementing it in Java presented a few unique challenges, like the fact that tail recursion isn't viable in Java, so you have to do it iteratively if you don't want to run into Stack Overflow exceptions. So here we have an iterative ANN. This just sets up the main sets up your initial services. So we have a setup service, a ANN service. We're going to build the network, then we're going to get the sample sets from the ANN, the setup service, and then just run it for however many times the user wants to run it. And for every run, it will update an epoch cost. And so then after a epoch is run, which is just the sample set of 16, it will get the overall cost of that and then adjust the weights dependent on that. So let's go ahead and run it. And we'll just choose 20. And yeah, so we settled on a local minima around a cost of 6.6. We started out with a cost of 126, the cost being the difference between the expected output and the actual output for each pixel. So that's an average of 6 over 16. So it's a difference of only half a decimal or so for each run. So yeah, so we do this by setting it all up. Obviously, the ANN service for each run will run the layer from the inputs to the hidden layer, and then using a set of node connections, transform each value into the next set of nodes. A node being just an activation, a height, which is just where it is in relation to every other node vertically, and then deltas, which are an average of how much the last layer should have changed. Node connections are similar. They are a set of two nodes, one from, one to, and then a weight, and then a bias to add, and then which layer is, or their position horizontally in relation to every other layer. Yeah, and then the pixel set is just something for the input. The ANN service will run those as we saw before. The adjust weight, you just get all of the deltas and then average them. Running the data for the layer, you take in a layer, which is just a list of nodes, and then take in all of the connections, find the connections to the next layer, and then do the activation for the next layer, and that gets the activation for the next layer. Then you do that again, and you have it for the output. This is just a singular layer ANN, singular hidden layer ANN that has the same number of nodes as the input layer. So that's why the local minima is a bit higher than it could have been, but my computer couldn't handle a lot more than that. So yeah, I hope you like the program. Yeah.